In this tutorial, we'll look at a complete process for creating a tiled public square using a single RailClone style. So we'll start with the source geometry and build the style from scratch. The geometry for this example is simple. We have a tree basin, a similarly sized large paving slab, a full length boundary piece, a half length boundary piece, a full brick, a half brick, and a central paving piece. The half length pieces are important because we'll use them to offset joints. In particular, the half bricks will allow us to create a running bond layout later. Start with the spline that defines the perimeter of the public square. Create a new RailClone object and open the style editor. Select all of the paving geometry in the scene, then right-click on the style editor and choose Import Scene Selection. Next, select the perimeter spline and import that in the same way. We now have everything required to build the style. The source paving objects already have materials applied to them. To use those materials in RailClone, go to the Style rollout and enable Use Segment Material. To fill the paved area, add an A2S array generator. Wire the rectangular perimeter spline to the generator's clipping area input. Then open Settings, General Settings, scroll down and enable Extend XY Size to Area. This means the array will now extend to fill the area defined by the clipping spline. We'll start by creating the row containing the large slabs and the tree basins. Wire the large paving slab segment into the generator's default input. To make it easier to see what's going on, go to the RailClone Objects Display rollout and make sure Quick Mesh is enabled. At the moment, the area contains only the regular large slabs. We can introduce the tree basins using a sequence operator. Add a sequence operator and wire the large paving slab into one input and the tree basin into the second input. The sequence will now alternate between paving slabs to tree basins to paving slabs to tree basins and so on. You can control how often either segment appears by changing its count value in the sequence operator. So this sequence operator creates its pattern on the x-axis. We now need to build different paving bands across the y-axis. So we'll add another sequence operator after the existing one and change its mode to y. We can now add each of the different paving rows to this sequence by wiring the full length boundary segment into the next input of the y sequence. The boundary row is added above the large slabs. However, because the boundary segment has exactly the same length as the slabs, all the joints line up. Now that may be the effect you want, but if not, we can offset the boundary joints using a half length segment. To do that, add a conditional operator before the boundary row. Wire the half length boundary into the true input and wire the full length boundary into the false input. Open the conditional operator settings and set the condition to segment x counter equals 1. This condition means that if this is the first segment in a row, use the half length tile, otherwise use the full length tile. Next we'll add the brick paving. Once again we have two segments available, a full brick and a half brick. Start by wiring another conditional operator into the next input of the y sequence operator. Wire the half brick to the true input and the full brick to the false input. In the conditional operator settings, enable x counter equals 1 to ensure that we're targeting the first segment in the row, but also now enable y counter and set it to multiples of 2. At first, this produces the incorrect result. The half brick is used at the start of the first row, but when the y counter is a multiple of 2, the condition affects the whole row. We only want the half brick when both conditions are true. And so to do that, change the conditional operator's combine mode from OR to AND. This offsets the joints and creates the running bond pattern. We can add as many rows of running bond pattern as we like by changing the count in the sequence operator. Next, add the central paving piece. Wire its segment to the next available input on the Y sequence operator. Then again, wire the conditional operator used for the running bond bricks into the next input of the Y sequence again and set its count. I'm going to use 3. Next, add the boundary piece again to complete the pattern. RailClone repeats this sequence across the entire area, creating the complete paving system. And because the layout's procedural, you can change the pattern at any time. For example, changing the count values in the sequence operators to increase or decrease the number of rows. With the paving complete, the next step is to use the tree basin's positions to place trees with ForestPack. Open the tree basin segment settings and enable Export to Forest. That's all that's required to make those RailClone segments available to ForestPack. Now at the moment, the tree basins appear at quite regular intervals. If you wanted a less uniform distribution, you could randomize whether RailClone uses a tree basin or a regular paving slab at each position. And to do that, you'd add a randomize operator after the tree basin segment. wire the tree basin to one input, and a regular large paving slab to the second input. And then if you select the randomize operator, you can adjust the probability values to control the likelihood of a tree basin being selected at each position. This could give you more variation in the layout while keeping everything inside the same procedural RailClone style. With the RailClone paving complete, the next stage is straightforward. We'll create a new ForestPack object from scratch and use the tree basin positions exported to RailClone to distribute our trees. So start by selecting all of the trees you want to use, go to the ForestPack Create panel and enable icon mode. Enable Populate from Selection and create a new ForestPack object. Populate from Selection automatically adds the currently selected trees to ForestPack's geometry list when the object is created. Open the distribution rollout and change the distribution mode to Reference. Click on the plus button and select the RailClone object that we created in the previous steps. Initially, ForestPack will place just one item at the RailClone object's pivot point, but that's not what we need. Instead, we want ForestPack to use the individual RailClone segments that we previously marked for export. So enable Use RailClone Items, and ForestPack will now place an item on every RailClone segment that has Export to Forest enabled. The trees are now positioned correctly, but we can also introduce some variation to make the result look more natural. To do that, open the Transform rollout and enable Rotation Randomization and Scale Randomization. You can adjust the settings to suit the trees and the amount of variation that you want. And that's all that's required to target ForestPack geometry onto the selected RailClone segments. But there's another option that gives us more precise control. So far, ForestPack is using every RailClone segment that has Export to Forest enabled. However, you can also label different types of exported segments using tags, and use these tags to control which ForestPack geometry is placed on them. For example, suppose we want to continue placing trees on the tree basins, but also randomly place benches on some of the large paving slabs. To do that, we first need to identify the different pieces of geometry in the RailClone style. So open the RailClone style editor, and then after the tree basin segment, add a tag operator. In its tag list, enter fpgeom equals tree to identify those exported segments with the name tree. You can now use the same approach for paving slabs that will receive benches. Add another tag operator after the paving segment and enter fpgeom equals bench. So instead of enabling export to forest directly on the segment node, add a transform operator after the tag operator and enable export to forest there. Add a randomize operator and connect both the exported transform branch and the non-exported branch. This allows only a random selection of the tagged paving positions to be exported to ForestPack. I then adjust the probability settings in the randomize operator to control how frequently paving positions are made available for benches. We now have two types of exported RailClone items, the tree basins and a random selection of paving positions for benches. Next, we need to tell our existing ForestPack object which of these exported positions should receive trees. So select the ForestPack object containing the trees and reopen the distribution rollout. Enable Match Geometry by Name. Open the geometry list and rename every tree that you want to distribute on the tree basins to tree to match the name of the tag. And there's one additional step. At the moment, there's no geometry in this ForestPack object with a name matching the bench items. When ForestPack can't find a corresponding name in the geometry list, it falls back to a random selection from the entire list. And that allows trees to appear in positions intended for benches. So to prevent that, add a new item to the geometry list, but set it to disabled. Rename this disabled entry bench. ForestPack will now match the bench positions, but because the corresponding geometry list entry is disabled, nothing is scattered there. We can now create a second ForestPack object for the benches. And just a quick note that if I wasn't randomly rotating the trees, of course I could have done this in a single ForestPack object, but I don't want the benches to be randomized, so I've split it to a separate ForestPack object. So we'll select the bench geometry in the scene, go to the ForestPack Create panel, enable icon mode and populate from selection, then create a new ForestPack object. The selected bench will automatically be added to the geometry list. Open the distribution rollout and change the distribution mode to reference. Click the plus button and select the same RailClone object from the scene. Enable Use RailClone Items, enable Match Geometry by Name, then open the geometry list and rename the bench geometry bench. ForestPack will now match the bench geometry with the RailClone geometry of the same name, but we also need to prevent benches from appearing on the tree basins. So just like we did before, we'll add another entry to the geometry list and set it to disabled, and then rename this disabled entry tree. The second ForestPack object will now place benches only on the exported paving positions and ignore the positions reserved for trees. And that's the complete setup. RailClone handles the procedural paving layout and determines where different types of objects are allowed to appear. ForestPack then uses those exported positions to distribute the trees and the benches. And because the two plugins remain connected procedurally, you can continue editing the RailClone style, changing the paving pattern, the number of rows, the location of the tree basins, or the probability of bench positions, and the scatters will update to match.